In this video today, we're going to talk about composition of functions, or composing two different functions. Right? This is yet another way to create a new function. This is slightly more complicated than what we did before with adding, subtracting, multiplying, and dividing functions. Okay? So think about it this way. So let's say I have two functions. Right? Typically, how does a function work? A function works where I give some input, right? And then that goes into the function. That's my input to the function. So let's call this f, my function f. And then it gives me some output, right? And that's how a function behaves. Now, and then obviously you have same thing for gx, where I have an input. And again, this function g does something to my input and gives me another output. Okay? So the way this is going to work for us now is when I compose two functions, the output that I get from f now becomes an input for g, right? So the way composition works, right, we're composing the two functions together. That means I give an input. That input goes to, let's say, my function f. That gives me some output. And this output now immediately becomes the input for the function g. And finally, g will give me some output, right? And so this whole thing here, right, now we've combined two functions, right? We are having two different functions in there, and we're going to call this a composition, or we denote this by FOG. Okay, and that is what we call a composition of two functions. Here's another example. Remember I told you about the soda can machine, right? That I put in a coin and I get a can of soda. Imagine I had two different machines, right? One machine was I put in a coin and I got a can of soda. And for every different coin that I put, so let's say I put a quarter, I get a Pepsi. Let's say I put $1, I get a Coke, so on and so forth. I get different sodas for different coins. Let's add a different machine that gave me candy. And the only input this machine took was sodas. It didn't take money, right? So what would happen? I would put in my coin, I would get a soda, and that soda, which is the output for the first machine, now goes in the second machine, becomes the input, and it gives me some sort of a candy. That's pretty much how the composition of function works. So let's get a more formal definition of composition of functions, right? So let f and g be two functions. Then we define the composition of f and g as FOG of x. Remember, this is an O, it's not a multiplication sign. All right? This is f of g of x. And we read this as f of g of x. Okay, so again, gx, which is my output, now becomes the input for fx. All right, so let's take a look at this example. We have fx equals 2x squared plus 3, and gx equals x plus 1. What we want to do is we want to find two different combinations. One is FOG of x, and the second one is GOF of x. All right? Remember, they're not the same thing. They might end up being the same thing, but it doesn't have to be. So, by definition, we know that FOG of x is f of g of x. Right? That was our definition for composition. Now, what I'm going to do now is, what is g of x? G of x is x plus 1. So we're going to go ahead and replace the g of x by x plus 1. And so this becomes f of x plus 1. Now, what is f of x? We know that f of x is 2x squared plus 3. Right? So what is f of x plus 1? Well, where do I see an x? I'm going to go ahead and replace that with an x plus 1. So that's going to be 2 times x plus 1 squared plus 3. So this is going to be 2 times x plus 1 squared plus 3. If I want to simplify this, this is going to be 2 x squared plus 2x plus 1 plus 3, or this is going to be 2x squared plus 4x plus 5. Okay. Now, example B, we want to find g of f of x. Well, it's kind of like the opposite, where this is nothing but, by definition, this is going to be g of f of x. So here, g is not my input, but f now becomes the input. So I'm going to replace fx with what it is, that is 2x squared plus 3. So this is g of 2x squared plus 3. Well, let's take a look here. What is gx? Well, I know gx is x plus 1. So what is g of 2x squared plus 3 going to be? So wherever I see an x, I'm going to replace that x with 2x squared plus 3. And so that's going to give me 2x squared plus 3 plus 1, or 2x squared plus 4. So g of 2x squared plus 3 is nothing but 2x squared plus 4. So this is your FOG of x, which is 2x squared plus 4x plus 5. And then we have GOF of x, which is 2x squared plus 4. So now I want to compose f with itself, right? So this by definition is going to be f of x. And so this is going to be f of 2x squared plus 3, right? And what does f do? Well, f takes the variable in, the expression in here, squares it, multiplies it by 2, and then adds a 3. So that's going to be 2 times 2x squared plus 3 quantity squared plus 3. All right. Or we can write this as 2 times 4x squared, 4x to the 4th plus 12x squared plus 9 plus 3. And if I simplify that further, I would get 8x to the 4 plus 24x squared plus 21. Okay. And then finally, I have FOG of 1. So here, same process, except the value of x now is 1. So this is going to be f of g of 1. Well, what is g of 1? I know that g of x is x plus 1. So g of 1 is going to be 2, right? Because I'm going to put x equal to 1. So this is nothing but f of 2. And so then f of 2 is 2 times 2 squared plus 3, which is 8 plus 3, which is 11.